All right, remember, for any calorimetry problem, the first thing we need to do is figure out what are the different things that are exchanging heat. So if we look at this problem, we can tell right away that there's at least one term that's going to involve combustion. So we can write Q combustion, we can write Q reaction, whatever you like. We can also tell that there's water. I mean, it's pretty clear. It's telling you water absorbed the heat. So this one's not particularly tricky. Okay. Question is there anything else? Well, it says that the water absorbs all of the heat of combustion. And to me, that suggests that there's actually not any heat that's gained or lost by the calorimeter, since the water is absorbing all of that heat. So just two terms here, just the combustion heat and the water heat. Next, we need to think about what to plug in for each of these things. Remember, combustion is a process, so we can't use either C delta T or MC delta T. Q of water, on the other hand, it's water before, it's water afterwards, and it's a pure substance that we know the mass of. So we can use MCAT for that water. Okay? Hello? Where's the end of our T? There it is. Q combustion. Let's just keep it as Q combustion for right now, but in a little bit we're going to substitute in something else for it. Okay? So we're told that the heat of combustion of CH4O of methanol is negative 725 kilojoules per mole, and we know how much of methanol we burnt. So we can either do this here or off to the side, but we need to do a little stoichiometry thing to figure out the heat of combustion of methanol. So we can say something like, I'll do it here instead of off to the side, 0 equals 1.55 grams of methanol, CH4O, times 1 mole of CH4O over its molar mass. I'm going to try and do this in my head. 12 plus 16, let's do it this way. 16 plus 4 is 20, plus 12 is 32. And there's going to be a little bit left over. I think it's 32.04 grams. I might be wrong. And then we're going to, oh, silliness. We're going to multiply all this times the heat. Where is it? Negative 725 kilojoules per mole of CH4O. Okay? This next part's a little bit obtuse. We actually need to write the balanced equation here, and I'll show you why in a second. Okay, so when we balance this, we'll have two H2Os, and that means we'll need to have two O2s. The reason this is important is that we need to know what the coefficient is in that box, because that coefficient here has to show up as the same coefficient there. So there's an invisible 1 here. We need a 1 there as well. Okay. In any case, when you multiply all this out, you get, plus, let's finish this, plus the mass, it was 2,000 grams, because initially we had 2 liters of water, times the specific heat of water, 4.18 joules, grams degrees Celsius, times delta T. You can plug all this in and solve, and I'm going to do that right now. I get a 4.19 degree temperature change. Is that the right number of sig figs? Yeah, no. We probably want to say just 4.2 since we only have 2 sig figs on that. So rather than that, okay, now one last comment about this problem. I'm going to show you a spot where many students will make a mistake. Joules here and kilojoules here. Make sure that when you're doing a problem, one of these stoichiometry problems, make sure that you have your units of energy matching up so that they cancel appropriately. There it is. Don't screw up the simple arithmetic either. It's a common mistake. Don't let that happen to you.